of Northeast India getting cut off from the rest of India. 1.3 kilometer embankment was also washed out in Eklagi Balughat section. Conditions were very adverse as disruption of road and rail connectivity made mobilization of material and manpower very difficult for restoration. However, NF Railway went all out to face the challenge and immediate restoration was started at all the sites. Most critical was bridge number 133 in NJP Malda section, where about 50-meter approach at the Malda end of both up and down bridges were washed out and scoured to a depth of 14 meters. A 24/7 control room was set up and movement of material, manpower and machineries monitored round the clock. Restoration of the 50-meter washed out approaches on bridge number 133 was the biggest challenge. Work was started from 16th August round the clock by filling of boulders to prepare the base. General Manager NFR visited the site and it was decided that for early restoration, CC grip shall be used over the prepared boulder base to support the track. 500 to 600 laborers and 13 hook lads worked round the clock at site. The Indian Army chipped in by constructing a pontoon bridge to facilitate easy movement of loaded dumpers for faster preparation of the boulder base. Finally, on 28th November, with the rolling of the fast tower wagon and subsequently light engine at 17 hours, the gap was bridged and connectivity of the northeast to the rest of India was restored. It was due to the toil and sweat of hundreds of dedicated laborers, railwaymen, and the meticulous planning of railway engineers that such a feat could be achieved.
Thank you very much. One important lesson which could be drawn from this is that when we are making bridges on new lines, we have to be very liberal as far as the waterway is concerned and not be stringy as far as providing additional bridges and so on. So the next presentation will be re-girding of road under bridge number 38 at Allahabad on NC Railway by Shri Rajiv Ranjan Kumar.
Good afternoon, sir. I am going to present the methods, planning and execution activity of the regarding of road under bridge number 38 that is situated at Allahabad East End on Howrah New Delhi Rajdhani Road. This bridge consists of two non-standard semi-through girders. One girder is having 3 tracks. One track goes to Rambagh line of any railway, and next track goes to Prayag line of Northern Railway, and other is Sunting Neck. And other girders consist of 2 tracks of main line, up main line and down main line. Why replacement is required? Actually, this was a very old girders of year 1903. This condition was very poor, and there are heavy corrosions. There were heavy corrosions in cross girders, stringers, and rivets. This is the work and contract details. This work was sanctioned in year 2005-06. And contract awarded in 2008, and this was completed in 2016. The completion cost of this work was 2.03 crores. These are the site constraints: heavy road traffic, built-up area adjacent to the bridge, number of cables passing through the bridges, limited space for working 2 cranes at a time. There is a complex OC network on both sides. No approach road to reach on track. We have studied the various methods, but most suitable method was to use the 2 number of cranes of 200 capacity with available site conditions and different constraints. This is the work planning. Initially, the work was planned with the replacement of a steel girder to steel girders, but due to site constraints and built-up area around the bridge, it was decided to replace the old girders with PSC slabs by reducing a span with introduction of one central pier. The work was planned in two phases. In first phase, the work of Rambagh line, Parag line and Santing neck was taken. In second phase, girders of main line was taken. These are the details of work involved for re-girding, casting of slabs, blast retainers, bed blocks, shifting of 11 kV electric cables of State Electricity Authority, which was a major hurdle there. This is the bed block what we have provided there. Weight 1.8 metric ton, M35 is a concrete block. This is the blast retainer, weight 8 metric ton, M35. This is the PSC slabs, M50, weight 16 metric ton. This is the pre-stressing detail, concrete M50, number of stands 51, standard of loading 25 ton of 2008. This is the phase 1 block requirement. There were 3 lines. Block requirement was 320 minutes, 360 minutes and 430 minutes respectively for the 3 lines. This includes 210 minutes of OG block. These are the details of material machinery required at site. Number of crane operations is very high. In first phase itself, 52 number of crane operations was involved. Girder removal, 3 number of crane operations, placement of new bed blocks, 12, placement of new PSC slabs, 27, placement of blast retainers, 4, placement of tracks, 6 numbers tracks. This is the phase 1 work, pre-block activities. Some important pre-block activities have been inaugurated here. Removal of debris from the sides to create working space, removal of earthwork behind the bed block, dismantling of brickwork, assembling of new tracks to be laid. This is the pathway prepared. This is the hoardings and cables. Actually, this shows the built-up area around the bridge, how much congestion is there. To place 2 girders at a time is also very difficult. This is the photograph of various activities, removal of earth behind the bed block to create a space for placement of bed blocks, brickwork removal between the bed blocks, preparation of road over tracks for placing JCB machines and Hydra machines to operate secondary works. This is the preparation for crane placement. This is a slab placement arrangement. These are total slabs. How these slabs could be placed there? It is clear from this view. This is the placement of road cranes. 2 cranes of 200 capacity were placed there. This is the block activities. Traffic block granted. A block was held on 28 February 2016. This is the cutting of girders, which was done during block. This is the OC lowering. How the removal of first piece of girder was done. This is the second removal of second piece of girders. Removal of third piece. Removal of bed block with the help of JCB machines and Hydra. This is the placement of blast retainers with help of 2 road cranes. This is the placement of slabs, house slabs were placed there. Placement of blast bags over the slabs. This is the placement of tracks from the BFR. This is the track placed on the PSC slabs panel. This is the OHE erection after after completion of first phase. Work completed. This is the photograph of completion of phase 1 work. Phase 1 work was completed. On the basis of experience of phase 1 work, phase 2 work was planned. On the same pattern, this work was also completed. Number of train operations was 38 numbers because only 2 tracks have to be handled. This is the traffic block granted. This is the completed. We completed the complete work here. Thank you.
Thank you very much. We come to the final paper of today's technical session by the talented Mr. Harsimran Singh, Canadian Coordination Adra, leveraging developments in monitoring technology for optimizing track and bridge maintenance.
Respected ME sir, GM sirs, AM sirs, respected retired and senior, retired and serving senior officers, my dear colleagues and friends, very good afternoon. This is a paper on leveraging developments in monitoring technology for optimizing track and bridge maintenance. It's been presented by myself and Mr. Saroj Kumar Biswal, SSCPP Planning. Sir, our basic outline is what are the objectives, the existing practices, the recent practices in our division, and basically the objective of using these modern technologies is to achieve the goals. What are the goals basically? Cost-effective monitoring and preventing failures of assets in time. It's high time that now we are going ahead and focusing on the modern technologies and trying to remove our age-old traditional practices of monitoring and maintenance. Nowadays, very low cost but very effective technologies are available, and we can very well make use of these. As far as the existing system is concerned, we have got manual and mechanized monitoring. We have got keyman, mates, inspectors and officers. They are doing various inspections on foot, push trolley and in engine and rear vehicle. And thereafter we have developed mechanized monitoring in the form of TRCs, OMS and oscillograph cars. Recently now we have started using Sperry walking sticks for USFD. We have now gone for in a large scale for route data preparation system, that is RDPS. Then we have moved to Android based GPS, OMS, and recently we have now gone for GPS tracking system for inspection trolleys, patrolmen, keymen and others. This Sperry walking stick has about 25% as per board instruction. We can do outsourcing by of USFD by Sperry walking stick. It is much more effective as far as USFD testing is concerned because it has got 9 number of probes in its RSU, Rollers Search Unit, and it covers about 100% of the head web and foot under the web, and can very well be installed in the vehicles also at 75 kmph. This route data preparation system, it's being done on a large scale on the railway, on the Indian Railway. In our division also we have done about 40%, we have got 40% of our track. And this is going to be the backbone for various technologies which are now coming up, like OMS, which is GPS based, and GPS trackers. Because without this, we will not be able to fully utilize those. It can cover up to 100 numbers of track features. We send a person with a laptop and he clicks wherever the features, whichever features are to be recorded, and all the coordinates of those features get recorded. Now the Android GPS based OMS, it has already been explained by other speakers. Basically it's a portable monitoring system which consists of a rail transducer unit, Android tablet and Android application. It's RTU, that is, it receives the acceleration information on the floor of the coach. The good feature about this is that it can be connected with the RDPS. It can tell you wherever the peaks come, that the peak was recorded at so and so location, there is a turnout over there, and it sends the SMS also, and immediate action can be taken. GPS trackers are being now provided to basically to the patrolmen, and thereafter we are going to provide to all other those who are working in the field. The basic purpose is to check the negligence of the employees in track inspection and maintenance, whether they are actually going over there, whether they are going for the full beat, whether they are going for the in the proper time. And another good feature is that whenever the person who is having the GPS tracker, when he sees some unsatisfactory feature, he can immediately press the SOS button, and the control and all other concerned officials come to know, and they can take preventive action immediately. These are some of the snapshots of this GPS tracking system for patrolmen. And see, these are the locations where the patrolmen are working. And this is a report which is generated. It tells the patrolmen moved in such and such area. Another topic which was about the bridges. Normally we are inspecting bridges on regular intervals by our inspectors and officers, and we are assigning certain ORNs, CNNs. But instrumentation of bridges is a very important feature. Whenever we are going to increase the loading, if we do the proper instrumentation, there may be many of the bridges which can be saved. Instrumentation has already been covered by many of the speakers here. I will just be telling about instrumentation which had been done a few years back in our Chandil Asansol section. It's a very long bridge, about 600 meters long, bridge number 520 over the Damodar river. These are some of the pictures which were taken during instrumentation. There is a screen, there is a data logger, there are sensors on the rails, on the members of the bridges. As per the results obtained, various peak stresses were recorded from the strain gauges, and they all were found to be within the permissible limit, and thus the higher loading was permitted over the bridge. There was another bridge 414. Similarly, all the stresses were found to be within the permissible loading. With the help of tilt meters and other gauges, the tilt, settlement and stresses were all recorded over a long period of time, for over a year, and all were found to be within permissible limits. With the introduction of these new technologies, we can simplify our working procedures, we can reduce the cost, we can reduce the manpower, we can basically do need-based track maintenance on a large scale. Rather than doing all maintenance randomly, better to go for the locations where the actual maintenance is required. By enabling the maintenance at correct locations as given by the Android GPS-based OMS which are connected with the RDPS, and the data and automated alerts provided, they create a vital time frame in which maintenance activities can be scheduled properly, and thus performance can be improved. That's all I would have to say. Thank you, sir. Thank you, Jay.
Thank you, Mr. Harsimran Singh, for a very interesting presentation. We now come to the end of this technical session. Only I would like to focus on is that we are having a large population of overaged bridges, so instrumentation, etc. is very important to know the actual health of our bridges before we go in for re-girding or rebuilding. There is also issue of loss of camber in some of our bridges. So before we actually propose re-girding, it will be an ideal thing to go in for instrumentation and know the actual health of the bridge before saying that it is an overstressed bridge and so on. So we would come to the question answer session, but I would like to ask my co-chairman to give his concluding remarks.
The presentation given by each author very interesting and thought-provoking. Recently in Railway Board also we have authorized Zonal Railway to carry out number of projects like scour depth by sonar waves, mapping of cross-section of river bed, continuous measurement of water level, robotic underwater inspection, and project on instrumented bearing for measurement of longitudinal loads. In addition, now the time is less, so we have received a number of questions to be replied by the authors, but I request each author to reply maximum 1 questions. They can choose any question and they can reply. The time is now almost finished. Start.
Thank you very much, audience, to show the interest even in the afternoon session. I have 6 questions, and I'll take liberty, sir. I'll reply in very brief. Otherwise, I mean, it will not be fair on my part.
Mr. Sacharya has got a very interesting presentation, so you can take the liberty of answering all the 6. Yeah.
Thank you, sir. Thank you. The first question is from host, Mr. Rajiv Rajwanshi. He has very relevant question. In fact, all the questions are very, very relevant, very interesting. Please confirm if the measurement of various parameters of monitoring, there is a threshold limit, and intimated directly to concerned officers by SMS, etc. This will be helpful. Otherwise, it will be required a control room, will increase cumbersome maintenance activities, etc. As I have already told that there is a limiting speed of wind that is 96 kilometers per hour, and earthquake 0.2 G horizontal frequency. So these are already limiting limits, and all other limits our designers have already given the limiting values, and all the parameters will be informed by SMS. So whatever you are telling is already there. Next question is for Synergy and Coordination, BKN, Bikaner. Whether prototype of the Chenab Bridge has been tested. So I just want to tell you that for the wind test, the prototype model was made, and it has been tested in Denmark in Force laboratory for the wind tunnel test. So it has been found that for 266 kilometers per hour, this bridge is safe. Next is SSE PWE, Mr. Acharya. If there is any instrumentation system installed over Chenab Bridge project to monitor the detrimental effect of earthquake, wind velocity beyond the prescribed range. As already I have covered in my presentation, that all kind of instrumentation are provided, like anemometer for the wind speed, accelerometer for the earthquake, etc. One more thing he asked, how you have designed this for earthquake. So as far as earthquake data is concerned, it has been taken from IIT Roorkee for the last 100 years earthquake data, and according to that the bridge has been designed for zone 5. Now next question is from Mr. VK Pandey, SSE PWE, Southeast Central Railway. Both ends of arch bridge slope of hill where bed blocks have been and bearing have been provided on variations for expansion joint ke bare mein aap pooch rahe hain. So I would like to inform you that since it is a continuous steel girder and 1.3 kilometer long, so 3 bridge expansion joints have been provided, not switch expansion joint, bridge expansion joint. And we have seen this kind of expansion joint in Po River in Italy, and in fact the order have already been placed on Oslo to provide these bridge expansion joints. Next is Mr. Vijay Singh, Deputy CEOH NCR. The instrumentation is done for stopping the trains when it becomes unsafe to run the train. It will prevent accident. Whether any consideration are there in design of the bridge by which the actual damage to the bridge foundation is known. So in this case also we have provided the accelerometers for designing the earthquake this thing. If earthquake intensity goes beyond 2G, then the traffic gets stopped. The last question, I had a fear from my senior Mr. S.N. Agrawal. मैंने आपको बोला था कि हमारे इस कॉलेज के भी सीनियर हैं और स्ट्रक्चर्स के मास्टर हैं, तो डर लगता है सर आपके क्वेश्चन से.